Morning everybody. We will start with the session. Interactive plotting is what we will start with. Please start IPython with the command IPython minus pylab. The slides, whenever you see an IN, that means those are commands you have to type. So start IPython with the command IPython minus pylab. As a general rule, whenever you see that IN square bracket, that means you have to type it. On your screen you will see IN with a number. We are skipping that number because on different people's screen it will be a different number. We do not want you to get confused with us putting one number and you seeing a different number. Let me repeat that IN square bracket is a signal that you have to type the command. We are not giving the number within the square bracket, but you will see a number in your screen. So after you type IPython minus pylab, you will see the IPython prompt, which is that IN. So type those two commands which appear there. You should see this picture on your screen. Okay, you should have got a picture like this on your screen. All right, very simple. Let's move on. What exactly did we do? When we said P equal to linspace minus pi 100, what we did is created 100 points in the range minus pi to pi. We can understand that better if you attempt to print what is P0, what is the first element, what is the last element, and what is the length. As you can see, minus pi, plus pi and 100. So linspace produces a list of the values, equispaced values. We can look at the docstring of linspace. IPython gives you the facility to consult the docstring by that. This will run for many pages, so we will not go all over. please note that it says return evenly spaced numbers over a specified interval, that is all. That is the simplest. So, you specify the start, stop and the number, it returns evenly spaced numbers over that specified interval, which is exactly what we want. Plot simply plots the two arguments with default properties. If you ever had to plot in other languages, you would have seen how much work it is in those languages and how simple it is in Python. Now, we noted that we said plot simply plots with default properties, that gives rise to the natural question. So, can we override those properties? Yes, and we can, and we should often do that, and that is for dressing up or embellishing your plots. Try out the commands here. This is the simplest type of embellishment. You can specify an output color for the plot. You can also specify the line width. You can notice that it has become thicker. Or CLF will clear your plotting area. Instead of a continuous line, we have plotted with a dotted line. Once again, plot question mark will give you lot more information. I will not show it here on the screen, please check it out, because my screen is small and at the large letters you will not see enough. On your screen you should be able to see enough to read. Remember this, when in doubt, just a question mark after the command will tell you. Alright, let us move on. Normally for a plot you need to do a lot more when you present one. We add a title here, let us check it out what happens. So, what does this command do? X equal to linspace minus 2, 4, 50. In the range minus 2 to 4, it will produce 50 equispaced points. X of 0 will be minus 2, x of 49 will be 4, and every point there will be equispaced. We plot minus x square plus 4x minus 5. Is that what we are supposed to plot? Let me verify. Yes, minus x square plus 4x minus 5 in red color at a line width of 2. Now, this is what you will see. Okay, I should have cleared it. So, here is the chart. Now, you would like to give this a title. Simply you can see the title. We can also use LaTeX. Whatever is enclosed within dollar is a LaTeX math expression, and Python will typeset it using LaTeX for you. See the difference? Actually, I shouldn't have done it as x star x. If I am going to use LaTeX, let us redo it. You can see the title now looks more like a mathematical equation than a programming expression. All right. Let us move on. We can also label the axis once again using LaTeX if you want to. You can see the x label, there is a x here. Now, the y label makes its appearance, it is here. As you can see, each feature or each command is additive. Whatever you do, it adds to the existing picture. So, we had the basic graph, then we added a title, it appeared here, we added a x label, it appeared at the bottom, we added a y label, it appeared in the left, and so on. So, the natural way is for commands to be additively going on to the output. This is on the other sides of the outside title and all, or outside the chart area. Even inside the chart area, you could do what is called an annotation. Let us do an annotation called local maximum. You could do annotation for anything. try it out. Let us move on to the before we move on, remember the one point about the annotation. The xy argument is a tuple that gives the location of the text. So, you want at -2, -1, that is x value 2 and y value -1. I do not, unfortunately I do not see it appearing here. So, -2, 1 is above this, that is why it does not appear. It is not part of the chart. So, let me change it. Okay, let us actually see where is the maximum. The maximum is at 2, -2 approximately. Then there is an error. 2, -1 is an error. So, it is not coming on the screen. I made an error. I typed it as -2, 1. So, there was no -2, 1 within. Now, you can see the word local maximum appearing here. The coordinates given are what are called data coordinates. They are not connected to the pixels, the size of the picture, they are connected to the xy values. So, where xy value is 2 and -1 is where it will be shown. Let us look at the chart we have produced, or let us look at the one of the earlier charts we produced. This chart, you do not get a feel for how the curve behaves, because the curve is touching the axis on both sides. We would like to have some space around. In a different context, let me show you something else. If you look at this picture, for example, there is this space on the left, there is this space on the right, the left, and the curve is actually touching the axis in the bottom and the top. So, we would like to give some, reduce the space on the right and the left and increase the space on the top. So, often we want to, the default decisions of the plotting tool about how to frame the plot are not something we are happy with. So, the way to change it is to use x-lim and y-lim. Let me have the chart redone, then so reproduce this. Now, we want to increase the margins on the right and the left. How do we go about doing that is what we will see. The command we use is xlim. Xlim gives you the current limit of x, limits of x, and ylim gives you the current limits of y. When invoked without any arguments, they will give you that. When invoked with arguments, they will set the new limits. Let us look at that. So, this is the x limit, as you can see, from -2 to 4, and this is the y limit -18 to 0. So, we would like to actually increase it, this to say -3 to 5. So, there is some space, we can do now. If you see the figure immediately, you will see space has appeared on both sides. Same way you can change the y limit. Remember, when invoked without any arguments, xlim and ylim will tell you what is the current drawing area's limits. When invoked with arguments, they will reset them. Alright, let us put all of this together. Okay, this consists of 4 plots, x equal to y equal to x and y equal to minus x, sin x and cos x over minus pi to plus pi, and the plotting area has been reduced using xlim so that there is no space on the both sides. Please do this exercise so that we can say that okay, whatever we have seen so far we can completely try it out once. Please add a title, please add a just add a title and the x and y labels. The 4 plots are y equal to x, y equal to minus x, y equal to sin x and y equal to cos x from minus pi to plus pi. All right, I presume you have been able to do that. Let us move on to the next item. In fact, that gives a good way to move on. Exactly how did I do it? You want to find out? Percentage hist gives you a list of all the commands I typed up to now. You try it in your machine, you will see it. You can see from the beginning all the commands we typed are here. Now the 4 commands I used to produce that chart was CLF of course, then plot p comma p for y equal to x, plot p comma minus p for y equal to minus x, p was already defined, then plot p and sin p, plot p and cos p, then set x limit, that is all. Now if the way you work is interactively you type commands to try out things, but once you have decided on what you have, what is the mechanism or what is the method to use in order to achieve what you want, you do not want to type again. You do not want to be going on typing the same thing repeatedly. So you can save the commands you typed into a script and run it. Try out the hist command first. It will give you the last 10 commands and so on. So these are the 4 commands I used. I have to add a linspace command. Now, if I can save this 4 somewhere, then I can reuse these 4 in order to repeatedly do the same thing, and that is what we talk about. Percentage save is the command. The save takes the first argument, it takes is the name of the script in which you want to save it, then the line numbers. The command as shown on the screen says save line number 1, line number 3, 4, 5, 6 and line number 8 into a file called plot_script.py. The command on the screen says save line number 1, line number 3, 4, 5, 6 and line number 8 into a file called plot_script.py. So, when you run the percentage save command, it will tell you what commands are written, and you can see the 4plot.py has been created as a file in the system. Now, if we open it with an editor, we can see its contents, it is the same lines I actually saved. It is a regular file. I am adding the linspace line. Now, this 4 plot is something we can run any time we want, if we want to redo this chart. All right. There are some additional issues. Anyway, we will do it now and be done with it. We will talk about y the minus I later. 4plot.py. So, it reproduced the plot without having to type it line by line. This is how you will find yourself working in Python if you are doing any preparation of plots. You will interactively try out a few things. Once it is settled, save it into a script and use the script to generate whatever we want. Of course, rarely we want to just show the chart, we may have to save it into a graphic file PNG and put it into a report and so on. How to do all of that we will see after the break.